The Vigenere cipher can easily be broken if we know the length of the key. Why? Well, let's assume we know the length of the key to be 6. Then we can split the text into blocks of this given length. Furthermore, we know that the first, second, third, and so on symbol of each block has been ciphered with the same key symbol. Hence, we group those symbols and analyze them like a Caesar cipher. That means counting the symbols in each block and assuming the most frequent one to be an E, because the symbol E is in English as well as in German the most common symbol in a text. The difference between E and the letter in the block is probably the key symbol for the appropriate position in the cipher block. The longer our ciphertext, the better the results. Even after this short text, we can guess 3 out of 6 symbols of the German adjective geheim, which means secret and is the used key in this example. Just a little bit more ciphertext and the key will be fully known. The real problem in cracking a cipher lies in getting the length of the key. Brute force is no solution at this point, believe me. So there were mainly 2 guys who solved this problem. The first one was Friedman and Kasisky and the second one William Frederick Friedman. Kasisky's method is a bit more practical but also not as accurate as Friedman's solution. Kasisky searched the ciphertext for repeating phrases of at least 3 symbols length and assumed that the distance between the phrases is a multiple of the key length. This assumption is based on the fact that the same ciphertext is presumably generated by the same combination of key and plaintext. The longer the repeating phrase, the more likely this gets. A length of 3 makes it probable enough. How to determine the distance between 2 repetitions exactly, you can see in the given example. We can now search in this little longer ciphertext for repetitions and find a lot of them. Searching with a computer program is at this point a very good idea. The determined distances are a multiple of the key length. In other words, the key length is a common divisor of the distances. Because it is just an assumption, there are some errors included. Those numbers we can just ignore. 12 or 6 seems to be good candidates for key length. This low number of possibilities allows us to just simply try and the cipher is broken. The solution of Friedman is less trying and more calculating. To keep this short, I just give the formula and spare the derivation. The coincidence index describes the probability to randomly pick 2 equal symbols out of a given text. A little math voodoo later, we are able to calculate the key length by just counting the symbols in a ciphertext and putting the result into the formula. The first formula determines the coincidence index of the ciphertext, which we calculate by counting the symbols ni and the text length n. The second formula is consisting mostly of constant values, depending on the language of the ciphertext. Fill in the values you need, as well as a formally calculated coincidence index. The nearest natural number to the result is the most likely length of the key, and knowing that, we can break the cipher easily. If you have any questions, leave a comment and I'll try to answer it ASAP.